Hi guys, let's see today's question. So today's question is based on the area which is enclosed in the curves. It says we have to find the area where two regions are given to us. The first region is x into y is less than or equals to 8, and the second region is y between, or I should say y is from 1 to x squared. First of all, let's understand the two regions and plot the graph, and then we will start with the solution of this question. So first of all, if you see x into y less than or equals to 8, it is of the form x into y is equal to a square, which is our rectangular hyperbola. So first of all, if you understand this will look like a rectangular hyperbola. If I draw first y-axis and x-axis here, this is y-axis, this is x-axis. Now, if I write it in the terms of y first, it becomes y is equals to a square by x. In this equation, if I write it, x into y is less than equals to 8. So y becomes equals to 8 by x. If I write it equals to maximum value of x into y is 8. So if I remove the inequality and if I write it equals to understand how the graph will look like, it is y equals to 8 by x. So if I put x as 0, you get y as infinity. And if you put x as 1, you get y as 8. If you put x as 2, you get y as 4. So basically your curve of this x into y is less than equals to 8 will be somewhat like this. It will be a rectangular hyperbola. And when the region it's said that it is lesser than or equals to, so all the values of x and y lesser than or equals to in the first quadrant, in the second, in the fourth, and in the third quadrant. So this will be the entire focused region for now. The next equation, if I see, it says y is between 1 and x squared. So first of all, if I write the left part of this equation that says y is greater than or equals to 1. So if I just write the maximum value of y that is equal to 1. Now we know this is a line which is parallel to x-axis and it is at a distance of 1 unit above the origin, right? So basically this would become the line which is parallel to x-axis and 1 unit above the origin. This is y equals to 1. So if y is greater than equals to 1, the entire common region here is all the area above this line. So if you see for these two curves, the common region now becomes this entire region which is above this line and below this curve. So this is the common region which is being followed. Now the third part, if I also focus on that, it says y is less than or equals to x squared. So if I write the maximum value for that, now it becomes y equals to x squared. Now if I see, this is a quadratic equation of the form ax squared plus bx plus, where a is 1 and there is no part of this constant value c, so it is 0. So what I understand from this is a is positive, so my parabola will be a u-shaped curve, and since c is 0, the y-intercept of this quadratic equation or this parabola is 0, means your parabola will touch y-axis at the origin. So let's draw that as well. So your parabola will look something. It will be a U-shaped parabola touching here. So now since this is lesser than y is lesser than or equals to x squared, means the entire region below this parabola will be satisfying this. So if you see the common region now for all the three curves, that is this common region, which is present. Right? So this is the common region for which we need to find the area of the question which is asked. So let's first find out all of these three coordinates and then we'll proceed to find the area for this. So first, if I want to find the coordinates for this region, so this common point is because of two curves. First is y equals to one line and the other is y equals to x squared, right? So y equals to one line and y equals to x squared. So I know the y coordinate of this point is already 1. If you put y equals to x squared, y equals to x squared, And if I put y as 1 here, I get x square is 1, so x becomes plus 1 or minus 1. But if you see, it is on the right hand side of origin, so x has to be plus 1. So I get the first coordinate, that is 1 comma 1. If I want to find the second coordinate here, it is the point of intersection of this parabola as well as this rectangular hyperbola. This point of intersection is intersection of the curves y equals to x square and y equals to 8 by x. Right? So if I equate both of them, I get x square and 8 by x are equal to each other. X cube is equal to 8. So that gives me x becomes 2 because 2 cube is 8. And when I put x equals to 2 in any of this curves equation, I get y is 2 square, that is 4. So this point becomes 2 comma. After that, if I want to find the third point, again I know it is lying on the line y equals to 1, so the y coordinate of this point will also become 1. Now if I talk about the x coordinate of this point, it is also lying on this curve, that is rectangular hyperbola, so it will follow this equation x into y equals to 8. So y is 8 by x, where we already know y is 1. So if I put y as 1 here, I get x as. So when I get x as 8, I also get my third coordinate, that is 8 comma 1. So basically now I understand that this is the region for which we need to find the area of the given two curves that is present between the two given equations. Let's find that. So if I now just focus on the common region which we got for the between the three curves, let's understand. The first curve was a parabola which looked like this. Then we had a part of rectangular hyperbola which looked like this, and we had a a parallel line to x-axis that was y equals to. So this was your line y equals to 1. This was your curve of rectangular hyperbola which said y is equals to 8 by x, and this was the curve for parabola which said y is x squared. Now, the entire region that is present for which we need to calculate the area lies between these three regions. So this entire area we need to calculate. Let's find out. So the area enclosed between the curves is given by the formula. Limits goes from x1 to x2, which is given by f of x dx, or it is also given in the terms of y1 to y2, which is given as f of y dy. Now we need to first understand whether we need to take a horizontal strip or a vertical strip. So first of all, let's understand that. So here, if you see, if I take here a horizontal strip, now this horizontal strip only goes from this parabola to this rectangular hyperbola from top to bottom, right? So the entire horizontal strip is valid for the area of the entire region which is asked. So if you see here, if you take the horizontal strip, you have the limits of y1 going from 1 to this coordinate, that was 2 comma 4. I'll first write the coordinates. This was 8 comma 1 and this was 1 comma 1. Now, if you use this horizontal strip, it gives you an answering by taking only one strip. But if you take a vertical strip, we will understand this after this solution, that how to solve the same question with taking vertical strip, and we'll also check whether we get the same answer or not, right? So first of all, let's take the horizontal strip, let's apply this formula and understand whether we get the area here. So area in this case, if you see, it becomes the limits of y1 to y2, means the strip is going from this bottom to the top. So your limits of y is from 1 to y equals to 4. So this is 1 to 4. Now function of y dy, right, dy here, let's understand the function. Function of y represents the area that we are finding. So area, if you see, if I take this rectangular hyperbola, the entire area below that comes. So I will have to subtract it from the area of this parabola and between the limits 1 to 4. So from this area, that is y equals to 8 by x. So if I want to write it here, x in this terms would make it 8 by y, because I need to mention it in terms of y as a function of y. So x, if I mention it, becomes 8 by y minus I am excluding the area of the part of the parabola that comes below this. So I don't need that area. I need only the area between them. So I will have to subtract this area, and this area, if I write again it in terms of function of y, becomes x as root y. So if I write it here, it becomes root y. Now you know directly the integration 8 1 upon y, the integration of 1 upon y is log of y, minus root y becomes y raised to 3 by 2 because it is y raised to half, y raised to 3 by 2 about 3 from 1 to 4. That gives me 8 log of 4 minus log of 1 minus 2 by 3, 4 raised to 3 by 2 minus 1 raised to 3. Now if I solve it further, it gives me 8 log of 4. Log of 1 is equal to 0, so it is becoming 0, minus 2 by 3. Now 4 raised to 3 by 2 means square root of 4. If I take first, it is 2, and 2 cube is 8, minus 1 raised to anything is always 1, so 1. So 8 minus 1 is 7, it makes it 8 log of 4 minus 2 by 3 into 7. So if I solve this further here only, it tells me 8 log of 2 square minus 14 by 3, or it makes it 16 log of 2 minus 14. So this is the answer by taking the horizontal strip. Now let's check whether by taking the vertical strip do we get the same answer or not. So instead of a horizontal strip, now if I take a vertical strip, I have already got the answer as 16 log 2 by log 2 minus 14 by 3. Let's check it whether we get the same answer with that also. So if I see again, the curve was between the parabola, rectangular hyperbola, and the straight line, where y was 1. Here x was 1, y was 1. Here the x coordinate was 8 and y was 1. And here you had x as 2 and y as 1. Now if you take a vertical strip, what happens? Let's understand. If I take a vertical strip, I will have to take two vertical strips such that the first vertical strip goes from this line y equals to 1 to this parabola y equals to x square. And after this point, what happens is you do not have a parabola here, you have a rectangular hyperbola. So you will have to take another vertical strip which goes from y equals to 1 to y equals to 8 by x. So now if you take this, let's understand how we will progress with the question. It goes from x1 to x2 and function in terms of x dx. Limits from x1 to x2, that tells me first vertical strip will have the limits of x going from 1 to 2. Function of x here, if you understand, it becomes this parabola means y equals to x square. If I find out all the values lower than that, so y equals to x square, so it becomes x square minus, if I do not want the area below this, so I'll subtract this area of y equals to 1, so it becomes 1. So x square minus 1 dx, plus if you see the other vertical strip has the limits from 2 to 8, and the curve, if you understand, it is 8 by x because y is 8 by x. Again, I do not want the area below this line y equals to 1, so I'll subtract y equals to 1 dx. After that, if I solve this integration, it gives me x cubed by 3 minus x. Limits go from 1 to 2. And here, if I solve this, it gives me 8 log of x minus x. Again, the limits goes from 2 to 8. So further, if you solve this, gives you 2 cubed by 3 minus 1 by 3 minus 2 minus 1 plus this gives me 8 log of 8 minus 8 log of 2 minus 8 minus 2. So further, if you solve this, it gives you 8 cube minus 1 cube, so 7 by 3. If I solve this further, it gives me 7 by 3 minus 1 plus 8. Log a minus log b is log of a by b, so log of 8 by 2, that is 4 again, and minus 6. So this becomes 7 by 3 minus 7, and this gives you 8. Log of 4, I can again write log of 2 square. So 2 comes in the front, it becomes 16 log of 2. And 7 by 3 minus 7 is 7 minus 21, so minus 14 by 3. So if you see here also, by taking the vertical strip, we are still getting the same answer. So you can take horizontal strip, you can also take vertical strip. If you're comfortable using only this formula, you will get the answer in both the strips. But only here you have to do two equations and you have to solve those two integrals. If you take a horizontal strip, you have to only solve one single integral. I hope you understood how to solve this types of question where we have to find the area of region enclosed inside the curves. I'll meet you again tomorrow with the next question. Thank you.